Okay, so let's start. Tom, Harry, you guys need to listen to this. Okay, so let's start with a sequence. I'm going to define a sequence as just an ordered list of numbers. So, for example, 2, 4, 6, 8. That's a sequence.
What the hell? Weren't you just teaching us your reference?
I was.
Yeah, and how we like having like what we're talking about.
All right. Now, see the second one? Numbers are the same, but they're in a different order. So, because they're in a different order, and I care about order in my definition, I'm going to distinguish these two sequences. Also, you'll see I've written 3 dots. What that's implying is the pattern continues. So, since we're a small group, I think I can actually just pick on people. So, Jason, what is the pattern in the first sequence?
2.
Yeah.
Plus 2. Hey, yeah, plus 2.
Great. Okay, Kaylin? Yep.
Plus 5.
Sorry, that's not what I want to do. Harry, what's the pattern here? Is your name Harry? Yep, Harry, what's the pattern? Yep, double? Great, excellent. All right, and Tom, let's go with you. What's happening here? Yeah. Sorry, 25. Thank you. No, that's my mistake. So one of the things you'll notice is you need to provide enough terms for the pattern to be obvious, and you need to get the terms right as well. Okay, so all of the sequences that we're going to study for the next 6 weeks, they're going to have a pattern. Right now, we describe the pattern using words. The main way we're going to describe them, however, is with something called a recurrence relation. So let's talk about that now. So if you were in my class last year, you'll remember this. I'll also say this was the topic where the most people needed to resit the test. Well, it's too late now. It's year 12 now. Yeah.
So surely you just shoot us a message whether we pass or
Or
just go around the classroom right now.
No, I haven't marked them yet. It's gonna take like 10 to 20 hours to mark the sacks, Jason.
I'll help you.
No, you're not.
Do it with
No.
you. Why not?
Okay. So, let me go back a step. So, does anyone remember from last year what a recurrence relation was?
T and 0
Plus 1.
T and 1
Mm-hmm.
B and
Okay, good.
plus 1.
All right, so you haven't forgotten everything. That's a good sign. All right. So if you're new to this, this is what's happening. Every sequence, we're going to say, starts at a term that we're going to call V0. Yeah, it was T last year, but you can use any letter. Okay, so this year, it's V. All right, the first number in the sequence is V0. The next one is V1, V2, V3, etc. Okay, so for example, what is V0 in the first sequence? V1, and V2. Okay. All right. What is V4 in this sequence? Say it again. 39. Yeah. So remember, the first term is V0. Okay. What would V5 be? Because I haven't written it in the sequence. Yeah. So you've continued the pattern, and what's the pattern? Increase by 8. All right. So that's good. So you know how to find these numbers in the list. You can read them off the sequence. The next step, which is really the heart of really the next couple of weeks, is I want to be able to describe the pattern without needing to write out all the numbers and figure it out by looking at it. All right? Because if I change the numbers so that I'm adding 29 each time and dividing by 1.5, it's not so easy anymore to see it just by looking at it. So what I want is a way to describe the structure of the pattern without having to write out all the numbers. And the way we do that is a recurrence relation. So let me write these out again. Okay, so this is what your recurrence relation needs. So a recurrence relation needs two equations. Anyone remember what they are from last year?
Tn plus 1.
So Tn plus 1 is part of the story, but it doesn't tell me much on its own. What's Tn plus 1 about?
Number at starting Isn't it like
Isn't it T0? And then there's Tn plus 1 plus the amount it's going up.
That's right. So let's imagine, so if you do want to pay attention to this one, let's say I told you that I have a sequence that goes up by 3. Okay? That's all I've told you. Is that enough to tell me that I have this sequence here? Why not? Yeah, you've got to define where you're starting. Because if I start at, say, 5, the sequence won't have the numbers here. So I need the pattern, but I also need to be told where the pattern starts. And that's the first part of the recurrence relation. The first equation is going to tell you an equation defining the first term, V0. The second part you're going to need, yes, Karen? Yes, you can. All right, let's ask it the opposite way now. Let's say I have a sequence that starts at 7. Is that enough to get this sequence here? All I'm telling you is it starts at 7.
no?
Why?
Because you don't know much going on.
Yeah, there's no pattern.
It's
So I need the starting point, number 1. I need a pattern, number 2. So you're going to describe the pattern using an equation defining what we call Vn plus 1 in terms of Vn. Now that might be a bit abstract. This is just saying if I have the current term Vn, what's the next term Vn plus 1? All right. So what I'm going to do is I'm going to give you the recurrence relation for these 3, and then I'm going to get you to do some yourself. So remember, you will always have 2 equations. The first equation will be to define V0. And this is the easy part. First term is just 2, 7, and 60. So you got to have that. And then the next part is I'm going to define the next term, Vn plus 1, in terms of the previous term, Vn. So you're always going to have an equation looking like this. Vn plus 1 equals something to do with Vn. So Cooper, what are we doing in the first sequence here to generate the next term? Well, just have a look at the purple writing up here. Look at that sequence there. Going up by 3, okay? So, thank you. So what we're going to do here is I'm going to take, every time I have a term Vn, to generate the next term, Vn plus 1, I'm going to add 3. Is that all right? So one of the things you need to do is if I give you a sequence like this, you need to be able to turn it into a recurrence relation. And remember, 2 things you have to do. Tell me the first term, tell me the second. All right, Kobe, what do you think is going to happen here in the second sequence? What's the pattern here? Plus 8. Very good. So you're just going to do plus 8 there to complete your recurrence relation. Harrison, third one? Yeah. So this time, instead of adding, subtracting. All right. I've changed my mind. I'm going to do one more example and then let you do some work. So we can also use recurrence relations to generate sequences. So probably tomorrow I'll draw a mind map with things going back and forth between sequences, recurrence relations, and formulas, which are later today. All right, so just stay with me just a little bit longer, and then I'll let you go to do some work. We should just break out in song right now. All right. So just have a look up here, guys. There's no sequence written on the board now. Or is there?
There is. There's a trick question.
The sequence is, I've got all the information I need to generate the sequence. I just haven't written out the first few numbers.
Yeah. You start with 5 and then you add 2.
That's right. So one of the things that you might be asked to do is a show that calculation, which means you actually calculate V0 and calculate V1 explicitly using the recurrence relation. So what I'm going to do here is I'm going to substitute n equals 0 into this formula. So on the right-hand side I'll have V0, and on the left-hand side I'll have V1. So this is what happens. To get V1, I add the number 2. V0 is just 5. So it's 7. V2 is V1 plus 2. 7 plus 2 is 9. V3 is V2 plus 2. It's 9 plus 2. 11. I'll do the same thing here. V1 equals 2 V0 minus 1. So Tom, I think you're distracted, so you can answer this question. All right. We didn't do this kind of recurrence relation last year.
Oh, yeah.
No? Because no one answered this on the exam last year.
Wait, would you just do 3 times 2 minus 1?
That's right.
And you keep going up.
Okay, so if you recall, we defined arithmetic sequences where we add the same number and geometric sequences where we multiply the same number. Here I'm actually doing both. So you haven't seen a sequence like this before last year, but you can still do the calculations to generate the sequence. Okay, so I'll just do one more. This time I'll substitute n equals 1. So v2 will be 2v1 minus 1. Notice that I'm replacing n with a specific value now to calculate a term. Okay, so that's, I believe, should be enough to get you started on exercise 7a. I don't think I want to lecture any longer because I can see that you're getting a bit restless. So I'm going to give you 20 minutes to work on exercise 7a, and then somehow I need to cover b and c. We'll cross that bridge when we get there. It's very important, guys, that you do chapter 7 properly, because a lot of the questions in chapter 7 are basically cut and paste from past exams. So if you can't do chapter 7, you're going to have real problems with chapter 8. You need to understand these concepts. So even though you're winding down because the term is ending, please make good use of your time this double period to get some work done.
Will that be on tape?